All right, welcome everybody. This is Fred Schenkelberg, and today's topic was a recommendation or a suggestion from one of our regular attendees. Thank you, Carla. And while I'm not by any means an expert in how to actually design a product and the enclosure or packaging that it would use to survive transportation, I do have a few ideas, and a few ideas I've seen in a number of organizations and ways to think about this and our role as a reliability engineer. So hopefully that'll help a little bit. It is, needless to say, a huge topic, a massive topic, and one that we do get involved in on occasion. But I fear oftentimes that it's not often enough or early enough. So let me dive into the topics, and we'll keep my fingers crossed that I don't get a complete screen failure here like I did a few minutes ago. We'll see how it goes. So anyway, we often, for the folks that are in reliability engineering, well, wait a second, let me make sure you can hear me. I didn't check sound, so let me do that. So how's it going where you are? I guess I should do it. All right, great. Thanks, David. Thanks. All right. I'd hate to get halfway through this and realize that I had my microphone muted or some strange thing like that. So anyway, for those of us in the reliability engineering that either are involved with product reliability, we may be actually working with teams to actually design in reliability or to do reliability testing or a range of different topics we can get involved in. At some point, our products get assembled. And we may get involved with the manufacturing process, with our contract manufacturers, with our suppliers, and in-house if you have all of those various elements. And we may get involved with how do we know that this product works when it's finished being assembled. Sometimes that's in a quality group, sometimes we get involved in it. If you're in the maintenance world, maintenance reliability engineering, we often are working with our teams that are looking at new equipment for the floor or assemblies or changes to the floor in order to insert the reliability elements into it so that we can maintain it. We can use this asset for a longer period of time or a long enough period of time. And we may be working with teams that are custom building equipment for our facility and get involved with the reliability part. But either way, our products, either we're purchasing them or we're selling them, get assembled. And let's try that. And then we move them. We move them from the end of our production line to eventually to the end user or the customer, right? And they get moved by hand, by forklift, by dollies. They get rolled. I bought a pellet grill this last summer, and the delivery guys brought it. It was, I don't know, 300-400 pounds. They brought it to the bottom of the stairs leading up to where the deck is, and they just rolled the box up the hill, or up the stairs, I should say. I don't know whether anybody would have thought that that was a viable or expected technique to navigate stairs. But fearing the worst, I opened it up and it was just fine. Their packaging was just fine. But we move it a lot. And customers then don't stop moving it. They might put it into their warehouse or the storeroom or in spares, and then they move it again. Or if it's a product, say a TV, you might move to a new home or move that TV to a new location in your home. typically we unbox equipment and then move it to where it needs to be. Some get unboxed and installed right where they sit for all kinds of reasons, but they often get moved even when their packing material is taken away. Now, eventually somebody uses the product. I thought about using nothing but images of container ships for this one, given all the supply chain problems, but it's obvious that it's not just the ships and the docks and the trucks and the warehouses and so on that we're facing these days. But eventually products do get to customers and they use them. And again, they might move that product. Now, one of the issues that runs into this is that we often, as a reliability professional, are kind of on the outside of, well, how are we going to ship this? What is the technique that we're going to use to move our product from our production line to the customer? And it's not necessary that we're part of that design of that tech, of the paths. And are we going to fly it to them? Are we going to do overnight deliveries? Is it going to be on a pallet? Is it not going to be on a pallet? Is it, there's a lot of decisions that get involved there. And think of it like a product design. There's a lot of decisions that occur that result in the reliability of that product, that influence the reliability of that product. Well, likewise in the shipping part of it. Well, how many times are we going to move this, and how many different environments is it going to be involved in as it moves from production to the customer and thereafter? Is there as much due diligence and effort put into how do we design the paths, the transportation paths, and the number of moves it makes and the types of moves it makes, including being rolled up a set of staircases, that also impact the reliability of the product, right? So how many times does your product move? Counting, it's at the end of the production line and it's got to go somewhere, and then it may be put into a box or maybe put in a box right in the production line. And then it moves to somewhere, maybe right onto a truck. Then where? Does it go to a warehouse? Does it go straight to the docks? Does it go into a container? Is it flown? How many different moves does it make? How many times does it change transportation mode, say from forklift to truck would be one count. So I got the chat window open. As you know, I often like to use that. So let me know, how many moves does your product experience on a typical day or in a typical path from production to use? I don't know. I'm taking the posit that you're counting up a good set of numbers here. Now, I used to be involved with the consumer product, the printers, inkjet printers. And once they were finished being built, they were moved by a robot. Well, they were moved by conveyor belt to a spot where they were inserted into a package. Yeah, count 5 to 6. Thanks, Carla. Good to see you here. But it would move with a robot into a pallet and then a forklift. Let me keep track here. Then a forklift to a truck. Then the truck would go to a distribution center if it was in the States, within access for a truck travel. And then it would be forklift to the warehouse, and then it would be repackaged into how it would look in the store, into a fancy box. So that's 5. And then it would be palleted again, forklift, truck to a distribution center to the store, say like a big box store of some sort, might order a whole pile of them. They'll break it down, put it in on probably other pallets onto trucks to the individual stores. Once it's at the store, it moves from the back out to the front. It may move on a dolly or it might move in a forklift. Depending on the type of store, it might just be hand carried out. Then the customer picks it up, takes it to the cash register, probably into their car or their truck, takes it home. Then it's moved by hand, typically into the home, unboxed, then moved to where it's going to be plugged in and used. So I lost count of that. There's like 10 times, let's say. All right. Yeah. And then mobile stuff, do you plan on it in the development of the product that it's picked up and put down, or moved one time a day, 20 times a day? It changes the risk for drop damage, for example. But we'll get into some of these things. So a couple, it moves a lot. Right. Let's see if I can get this to work. There we go. So here's the problem, the way I see it. Our development teams that develop equipment for your facility or a new product going out to customers, they focus on getting it to work, right? Especially early in the design cycle is basically, don't bother me, I'm just trying to get this thing to work. We have to invent 4 things, and I'm working on that. And we've got most of it working, but we're trying to get it to meet the requirements that we've come up with for this product. It has to be blue and only weigh 3 pounds, and on and on. What is its feature set that we're trying to create a device that actually delivers those things? Now, the focus is where it should be. It's on, we've identified a problem that our technology and capabilities and know-how can help a customer solve. Making a coffee maker, a customer wants coffee in the morning, that's a problem. They have lots of options, obviously. We want to do it uniquely. So we're going to give them this cool Hi-Zoots, Wi-Fi enabled, you can program it to different temperatures, all these cool things. And we got to make it happen. So we need temperature sensors. We need all these, how much coffee, all those questions that go into how do I create a product that a customer is going to see as a solution for their problem, and maybe some cool bells and whistles on the side. But when we will approach them and say, hey, we need to design this for reliability, and then the manufacturing team's right behind us or next to us, and she's saying, hey, we need to design it so we can build it, design for assembly, design for manufacturing. And then the customer service teams there and saying, hey, we need to design this so that it's repairable or has diagnostics in it. Oh, and by the way, we have to make sure it's environmental friendly, and we have to have the appropriate, we have to do, the supply chain has to work. So we have to design for that in mind, and on and on and on. Now, I've had more than one design engineer I've worked with and design manager saying, hey, stop it, you're just a distraction. Now, in some organizations, by the time you get to design for transport or design for shipping, it's so far down the list that it's just not on the radar at all. Now, some organizations do a little better than others, yet it's part of the noise oftentimes, especially when you're designing a product. And that's not always a problem until it is, where a product that is fragile for whatever reason and just doesn't survive transport. And the design team didn't take into account the set of stresses that it takes to move a product from one location to the next. A couple of good examples of that in my years. Now, another part of this thing is better design teams, and with reliability engineering support, we'll start to look at, well, what's the environment? Where is this product going to be used, right? But we often then focus on the end use environment. What's the customer's environment? What climate do they have? What temperature, humidity, shock, vibration? If it's a portable product, how often do they interact with it? What kind of pressures, what kind of torque is being placed on knobs and dials and stuff like that? We often get involved with what's the customer's set of stresses they're going to apply to a product. And then we go to great lengths to make sure the product will work in those ranges of stresses that we expect. Is it going to be used outdoors in northern climates in cold climates? Is it going to move from indoors to outdoors, from hot to cold or cold to hot, depending on where in the world you live? What's the internal temperature? Like a common question is, well, what is this effect of this use set of stresses when it's being used by a customer, right? And the idea is that the environment is real focused on the end use. We want it to last for 5 years in the customer's hands. And the thought is, well, the shipping group will figure out how to make a container, and it's only for a few hours that it's actually in transport, or a couple of days it's in transport, or if it's in a container, it might be a couple of weeks. And it's not being powered, so it's not in use. You can't fail when it's not being used, right? And I even had somebody argue this is the only time that we know that it's failed is when somebody tries to use it. So why do we worry about the shipping part of this? Like, well, and I showed him a picture of a forklift going right through the container, the package, and spearing the inkjet printer inside it. And he says, because it matters. Now, we're not going to protect from all stresses, but the stresses that it sees during shipment can initiate or cause failures to occur. And you're like, no, it can't. The only time it fails is when somebody tries to turn it on. Okay, well, that's a problem. That attitude is, oh, it'll be there. Just do it. Yeah, and you're exactly right, Michael. There are products that are sensitive to the shipping realm of them. Others, I mean, I ordered a pair of shoes the other day, and it showed up in a shoebox with a little bit of tissue paper inside it, and that was it. It had a label on the outside. It was taped up. And talk about the simplest process, but the shoe itself is going to see a much more rugged sets of stresses as a hiking shoe or work shoe in my garden than it would during the shipping process. But most of our products don't do that, right? Especially if it's sensitive or electronics or has glass, all of those kinds of things, it's not always true that the shipping is a benign environment for it. That doesn't always happen. And assuming that it will be fine, or that it can't fail when it's not being used, when it's in the package, isn't always true. And that's a mindset that I see way too often. The other part of this is that it's often an afterthought, unless you've got a dedicated engineer that works through how to design the packaging. I'm thinking of the Apple packages. They're beautiful. They're well thought out. They're elegant, and they protect the product. And it takes a lot of work to do that. I worked with a couple of different teams that have, spun off a couple of engineers to work through the packaging stuff. And they're not professional packaging engineers. And there is a whole discipline for that. But a lot of companies don't have a dedicated person to do this. They have somebody that mechanical engineer says, hey, I need to build a crate, or I need to sort out a box, or they outsource it. So it often gets, hey, we got to, at some point during our product life cycle, we got to figure out how to move this thing. And then we start thinking through, well, how will it move? Will it be on containers? Will it be on trains or planes or automobiles? Or what's the sequence of events? And then what's the types of environments it's going to see? And at that point, it gets pretty overwhelming. There's a lot that going on there that is fundamentally different than all of that work we put into how a customer uses the product. And so what do we do? How do we get this done? Because we don't want to have waiting for a box to be the delay for the program. And so we just get stuff done. And there's lots of paths for doing that. Right. So here's a question for you. If a product fails out of box, or when you first install it, it fails, say within the first day, or some organizations say for the first month, we'll call those out of box failures. Is that a reliability problem, or are we not interested in those? How's your organization view out-of-box failures? This gives me a chance to take a sip of water. What do you think? What's your opinion on those initial early failures that occur as soon as the customer gets the product? Yes, yes. It is a reliability problem, right? I guess I'm talking to the folks that get it, right? You've probably run into this where it comes in, if the product was failed within the first couple of hours or days or months, early failures for a product, it often gets routed to a quality group or to the manufacturing group to say that it was a manufacturing issue or a vendor issue or a shipping issue. And so there's some logic to that may be true. And they're directly in line with where all those sources of failures or damage could occur. Yet it then, in some organizations, they don't count it as a warranty problem, right? It might hit the warranty, but they don't count it because it was early failure. That was a manufacturing thing. That was a shipping thing. It costs us money. Right? It takes time and energy and resources from somewhere in our organization to replace the product, to diagnose it, to do troubleshooting, to execute repairs or fixes. It's a problem. I don't really care whether you call it a reliability problem or not. It's an issue that something failed, and it may or may not have, a design flaw, but it may well. And whether we get involved with leading failure analysis or troubleshooting or improving some part of the process, we're well suited to do that from the reliability point of view. Now, there are great quality engineers and manufacturing engineers, customer service folks, and all these people can play a role in this. Yet, if they're armed with good root cause analysis tools and all these other pieces of it, by all my counts, then they're practically just reliability engineers or technicians. And so they're working on improving the performance of the product so it lasts longer. That's all great. But from a customer's point of view, they don't really care. It failed. It's not working. I need it fixed. I want to return it, or I want it replaced, or I want it fixed. And they're not going to call it a reliability problem. They're just going to say, hey, it's not working, which is a reliability problem. All right. So here's a thought about what I see as the common approaches that people use. And you may or may not use some of these or all of these. So the first one I see is there's a standard. And depending on the nature of your product, if it's handheld or military, or if it's industrial or commercial or consumer, there's a raft of standards out there. IEC, the International Electro something or another Commission, Electrotechnical, I think is what it stands for. Anyway, ISO's got them, ANSI's got standards. There's SAE standards for the automobile industry. There's medical device groups of standards. There's toy standards. There's all kinds of standards. Many of them will include, if you're going to ship this by truck, here's a vibration profile, here's some temperatures to expect. And if you run so many samples in their box and drop it twice on two corners, or you do this or that, then here's how you know you're good for transport. Now, FedEx and UPS and others shipping companies will often have guidelines or ideas. Here's what you should expect. Here's your package needs to survive X. And here's the set of stresses that they would give. Now, it may be very conservative, or it may be missing some key elements, some stresses that your product is sensitive to. And it's the same with the standards. There's plenty of standards out there, and they don't cover everything for every failure mechanism that may exist in your product if it's exposed to the appropriate set of stresses, right? So there's two levels. It's not just that the package survives, it's that the product survives. So many of the standards and the vendor guidelines are talking about the package. They don't want the box to fall apart on their conveyor belt and it's a debris field and they can't move it. They lose the label, for example. So standards and guidelines tend to look at, will the enclosure survive? And one of the ways we go about testing stuff with common standards is that, is there any damage to the package? And if there's no damage to the package, some of the guidelines say it passes. Well, if I vibrate it and my product has a design feature that has a good size mass on a pendulum, essentially, think big capacitor standing up proud on a board with just two little thin leads under it, that capacitor could break that set of leads and fail. Or there's plenty of other examples. But if we don't make the internals to the product robust to the vibration that's seen and transmitted through the package to the product, it very likely could incur a lot of damage. ISTA, what's that one, Carla? Is that one of the standards over in Italy that you deal with, or in Europe? But there's plenty of different ones out there, and some are better than others, but they tend to focus on, if the package survives, the product will be fine. And one way we test it is we shake, rattle, roll it, we pull the product out, and does it work? Now, it's an international standard. Okay, so one of the issues I ran into very early on, I was working with a client that was making something, it was like a watch, but it wasn't. It was like a health tracker type thing, that's a wrist, a bracelet type device. And one of the things they ran into, and this is before I got called, was that they didn't have any standards for how much moisture sensitivity this thing would be used for. And they could label it, it's not moisture sensitive, don't wash your hands or swim with it, but it was an activity thing. So it was expected to see people running outside and in the rain or through puddles. Swimming with it was another activity that they expected people to do. So they kind of figured that it would be on your wrist and it would maybe get 3 feet deep, maybe a meter deep. So they said, well, we need some margin, which is a good strategy. So we'll say it should go down to, say, 10 meters and survive. And so they were looking, well, how do we make sure, how can we claim that? And so they went to the watch industry, where there's a whole group of standards for how well a watch, because they were looking at a watch that was rated for diving, and it could go really deep and have a lot of pressure on it and everything else and still function, which would be important if you're underwater, and work after repeated dives. And they said, well, we don't need that one, but they have different levels. So for swimming, the 10-meter one seemed to be a good level. And the test said, well, create 10 meters of water or equivalent, the pressure that it sees, dip your product into that pressure or that much water or under that much water, let it sit for a couple minutes, pull it out, shake off excess moisture. If it's still working, it passes. Now, what it missed was one of the key things that moisture does to electronics. Right? It creates corrosion, and corrosion's not instantaneous. And they were using tap water, which in some parts of the world is pretty clean. And so there wasn't a lot of contaminants there. If I'm swimming in the ocean, I got salt water, but that wasn't what the standard called for. It just says tap water or, clean water. And the other thing that's about corrosion is that it takes time, right? So if the moisture got into this device, it would work. And it would work for a couple of days or a couple of weeks, depending on temperature and how much it's moved and all kinds of other factors. Yet the test was instant. It was dunk it in, 5 minutes, pull it out, see if it works. And then they failed to notice or connect that every one of those samples that you used in the dunk test failed within a week. And they thought it was because they were doing all these random other tests, vibration and drop and all these other things, and didn't open them up to look for corrosion. They just count them as a failure. They're getting through their suite of standards-based tests and then ready to go. Now, that was on a product's feature, and in its use, it would be exposed to moisture. But the same applies in shipping. If you drop it, the package, or you put a vibration profile under the package, or to simulate a forklift or a truck, the common feature of many standards is that you then open it up and see if it works. And it's for some fixed amount of time that you apply these stresses. Now, it's a start, but it's generally disconnected from what we really need to know. So let's say another problem I see is that we'll just do a bunch of testing. Now, at the end of a program, when we got our shipping containers or boxes ready to go, and we've got a few prototypes, we're going to run over to the lab and do some shipping tests. We generally throw all the statistics out. We may have considered it during the product development cycle. How many samples do we need to account for the variability from product to product? So let's make sure that when we manufacture these things or test these things, that we account for the variability from unit to unit, because they're not all the same. And we know that. Well, I'm here to tell you that the shipping containers out of cardboard and styrofoam, typically, and the variety of other packing materials that we use or containers that we use have way less control of thickness, of capability, of shock resistance, of moisture sensitivity, of dimensioning than our finely tuned products that we make to exacting standards. They're close enough. Now, some of them are built better than others. The Apple ones if they decide they're going to put an extra 2 pieces of paper into it, it probably changes the dimensions of their package, because there's not a lot of extra room in these things usually. But the idea, though, is, and I've seen this happen, is a product had a instruction manual that would be added to the inside of the packaging. Kind of the last minute, this is, oh, we're going to sell this in North America. We got to put in the North American package. And then somebody realized late in the process, they said, wait a second, North America includes Quebec, and they want everything in French. And it includes Mexico, and they need Spanish. And there's parts of all 3 countries that have other languages that are part of our customer base. So we need to add other language support in here. So they replicated it, translated it into like 5 languages. And it was, you've seen these manuals. They go from like 4 pages that you can read, unless you know more than one language, to like 25 pages. Well, that wasn't taken into account in the dimensioning of the package. So now they put that book basically in the package where they were expecting to have 4 pages. And it changed the how much it was pressing on the product and how it transferred loads. So when they stacked these boxes, there was this pressure point where that change in the dimensions of the manual was, and it started to break. And once you got 4 or 5 of these on top of each other, it would break the top of the screen, the casing for this product, which is, think of a small computer, and it was cracking those. All because at the last minute, they said, oh, we got to add some more pages to the manual. Now, would a shake, rattle, roll, temperature, humidity type set of testing catch that? Probably not, right? So everything about packaging varies as much or more so, including the stresses that it sees, than the product itself, right? When we focus on the design and the assembly of a product, I mean, are we doing SPCs, statistical process control, on the packing materials? Probably not. And I suspect, and I've experienced it, is there is a lot of variation in those materials. And also, you know, when we're doing testing, one of the common ones, and this, many of you may have heard this story before from me. If the standard says drop it 10 times randomly or purposely on each corner and each face or something like that, or just drop it 10 times from whatever distance and do this, is that good enough? What does that really mean, right? Is it accumulating damage on your product, and is 10 enough to manifest those failures? Or is it really just looking for overstress where it's one drop and it shatters? Or if you hit it just right, it breaks. It varies, right? What we're looking for and how the packaging interacts with the product and what's internal to the product and how it sees those forces, whether they're amplified by the packaging or maybe dampened by the packaging, which we would hope. It not always, depends on the design of these two systems. 10 drops might be perfectly informative for us, but how does the standard know that it works for your situation? They don't. They often don't. They really don't. So you need to think through, what are those stresses? What's the variability? How many samples you need? What is the range of changes and stresses? Those kinds of things. And a good tip is always monitor, like if you're doing vibration, put it on the product, not on the package, or in addition to put it on the product, because you may discover that the vibration is amplified by your packaging, which is the opposite of what we typically want. So that's a good to know thing. Some companies I've run into said, we just don't have the time or energy, and we haven't had all that many problems, so we're just going to buy insurance. If the package shows up damaged through our shipping processes, we'll file a claim. And like, okay. So what do your customers think of this? Oh, they complain all the time. All right. So they get an out-of-box failure or they get a damaged product because the packaging was just an afterthought, not really thought through, not investigated. And the finance team is like, oh, we got it covered. We only pay $1 per $10 of damage that occurs. So it's not a big deal. We don't worry about it. Well, you know where I'm going with this is the customer is the one that discovers the shipping damage, right? By and large. And now you've got a customer that has an out-of-box failure or early life failure. Is that good customer service? Is that meeting their expectations? No, not really. And you know this. So insurance might be a financial benefit, but you really should never be filing claims. It just doesn't make much sense. Not for the much larger scope of your brand identity and customer satisfaction. All right. So before I get into a couple more top tips about what you can do, what do you think? What are the types of stuff beyond standards, beyond just testing to the standards or testing it in, basically, which we know is not always a good thing? What should we be doing? How can we prevent these failures from occurring? What are some of the techniques you would think would work? I suspect some of you or most of you have had to deal with this at one point or another. What is it we should be doing in order to prevent shipping damage from causing failures in our products? Yeah, in fact, I'm expecting a couple of packages today and it's raining. So we'll see how well those packages survive getting wet. Yeah. invest in a good package design. Oh, that's a good, yeah, HALT is a great idea. It's a step stress type process. In the process itself, I think it makes a lot of, warrants itself out pretty well. It's not a one and done type test. It's not 10 drops and call it a pass. It's go find out where the weaknesses are. I like that idea. I didn't think of that. FMEA, think through that. That and I from what I get gathering, Doug, it would be include that up in the development process. I suspect that it would be a good place to do that. Get a good package design. Yeah. You have to define what good is, right? Is the package survive with the product's pile of dust inside? It might be a great package, but it has to include getting the product there, right? There's a great one, Carl, is know what your weaknesses are. So the packaging needs to account for that, right? If it's really susceptible to vibration, then you need to take care of that. If it's susceptible to moisture, then you need to deal with getting the moisture out or maintaining a moisture barrier of some sort and so on. And it definitely is a challenge with online shopping. Yeah. And it is, as I can attest, we'll see how they do today with some shipping companies or the last mile shippers. One of them in our neighborhood tends to just kind of slow their vehicle down and throw it out the window, and it's right on the road, so it's prone to theft, but it's also usually in a really bad spot. Just how it got there. So yeah, and others take good due care, and if it's raining out, they'll find a dry spot or something like that for where I live. Some do better than others, but that's just one step in this overall shipping process. All right, so a couple of good ideas. You're on the right track as far as I can see, but that's kind of where I'm thinking is you need to do the design for transport or design for shipping. Now, we might not want to call it that because it's one of those, just another one of those DFX things. Oh yeah, we need to deal with that. But it's roll it up underneath your reliability part. It's a warranty reduction program, and if nothing else, an improved customer satisfaction pitch. It's part of the process of getting a product out to market is that it has to get there. Now, a couple of ideas that I've run into and have thought of as I'm looking at this, realizing that's a 747 there. They're still flying. There's still a few of them out there, but I think the fleets are being retired. So I need to update this picture. So part of it is like the HALT idea. Even if it's just on your product, if you make your product more robust, if it withstands vibration and temperature and humidity and moisture ingress and the handful of other stresses that occur during shipping that may be more or less severe than what you get in use conditions. If you make your product robust to that range of different stresses that are part of, that include the shipping process, you're less likely to have problems, right? But it's like that HALT idea is where it's, where are those weaknesses and can we design them out? Can we make it more robust to those stresses? Now, in some cases, if your product is going to be used, say, in a clean room, right? Well, it makes sense to make sure that your product is shipping containers maintains the cleanliness of that product, that it is able to be installed in a clean room without a whole lot of trouble in making that happen. But that sets up a whole raft of different types of stresses that can overcome those barriers to keep your product pristine or clean or free of contaminants. And it takes some effort to actually design a product and the package that work together to protect yourself from that. But the idea is that the shipping stresses, in most cases, most products I've worked with, are really pretty bad. I saw some data some years ago for the UPS trucks, the big brown delivery vans that we got running all over the place. the tops of those, if you notice, have a translucent roof to them so that they can get natural light into the back of the vehicle. And I don't know if all of them have it, but many of them do. And so think Tucson, Arizona, or Phoenix, Arizona, or Houston, Texas, or some other place where it's hot and humid or just plain hot. The driver is on his lunch break, pulls into a restaurant or a cafe or whatever, locks up the vehicle and goes in for lunch. Now, you've got this natural greenhouse effect that occurs. And what I saw was the measurements of the top rack and the back of one of these trucks. It could get up to like 80 C. That's hot, right? And if your product and your packaging don't survive those high temperatures for an hour or 2 hours, that could be a serious problem for your product. But that's not common in the standards, in that temperature range that it will see during shipping. They usually do averages, or it's typically Cs, or it's a 90th percentile values. You don't see that every day. Yet containers that come across on a perfectly calm sea, there's no big deal. You get some salt air and so on. But you go through a good storm, there's going to be a really change to the ability for these containers to protect your products from the moisture and the salt air and the moisture and the salt primarily. But there's also variance in our processes of petrochemicals from the vehicles, say forklifts and dollies that we're using, that gets on your packaging. Does it survive getting splashed or tainted by fuels or oils or debris or whatever? Can it take strikes like birds, for example, on your packaging? What if something's dripping on it in a faulty warehouse or a leaky truck? Just because it's in the normal shipping channels doesn't mean that it's not going to see a range of different stresses and types of variation that goes on to it. And so part of a technique that I've seen used a number of times is, we know that we're going to be using forklifts and trucks. And we're going to do pallets and then trucks, and then it's going to be hand. So for the hand part, let's put handles on the side of our containers so that the customer can pick it up at the store and move it up to their home. If it's heavier than that, then what are our options? How are we going to deal with that? If it's say forklifts and trucks is our primary path for getting their products out there, well, what do we know about those environments? So standards give us a start, but let's go measure it. Let's go figure out what those paths are, and then let's create a set of guidelines and then continue to improve those guidelines so that it feeds into the design process for the product and for the packaging. And just like we do for, good practices for assembly or good practices for approved vendors. I'm trying to think of supply chain best practices and minimizing the number of SKUs that we bring into a product. Let's take a look at, well, what are the things we know and don't know? What have we learned internally work and don't work? And let's codify it so that it doesn't get lost. If certain people leave the organization, if they take their shipping knowledge with them, we're starting over again. So let's capture what we know. Let's put some effort into saying, well, here's the types of stresses we're going to see. Here's the ranges of values they're going to see. Here's how we're going to evaluate these things. Here's the ones we've learned the hard way affect our product more so than others. And this just capture that information and make it available before we finish the design of the product and of the design or of the shipping process. So that's one idea. Another one is measure it. A friend of mine, when we used to work with Hewlett Packard, he sat across the hall from me, was basically the guru packaging guy in the company. And it was just about every week, he would take a little data recorder that measured temperature, humidity, and vibration, and would put it in a package, one of our typical packages, and would ship it to another HP facility on the other side of the country, other side of the world, and then ship it back. And then pull this little data recorder out and see what it gave us. And he was on the phone with FedEx one day saying, you've changed something in your distribution center in XYZ location. It used to be a 1 foot drop. Now it's 18-inch drop. You're going beyond what you say you're going to do. And this guy was like, how do you know? He says, were you in the facility? We don't do tours and stuff like that. And he goes, no, but I measure our packages. And they went through, I knew exactly where it was. It went through your distribution center where it typically sees a 1 foot shock drop from one conveyor belt to another. It was seeing 18 inches. We can replicate the profile that we're measuring in the lab, and we know it's 18 inches. And the guy in FedEx was just blown away. He's like, all right, I need to go fix that. I got to go find it. And, and then he did it regular enough that he knew the temperatures. He's the one that knew the temperatures in the upper rack of a UPS truck. He knew air pressures. He knew static discharge that was occurring in some of the rollers that weren't properly grounded. He could measure all kinds of cool stuff as he got better and better at these little data recorders. And those packages, those little recorders, are getting better and better all the time to where they're not adding a significant mass to your product. They can record for weeks. There's all kinds of cool stuff going on with them. They're a cheap relative investment to just check your paths. What is the actual environments you're going? Now, by doing it on an every week basis, he had all kinds of cool information that he could say, all right, I've done this 30 times over the period of a year. Here's our distribution of temperatures that we see. It correlates to the ambient temperatures, or it has a 10 or 15 or 20 degree temperature rise on the high end and on the low end. So we're protected somewhat from cold, or vice versa. But by gathering the data and presented it as mins and maxes, and not just averages, it was way more useful information, much like we try to get from our customers' use applications. We go measure how they use it, where's the stresses that are being applied, in order to understand how to design a product that will work for them. Well, the same applies to shipping. And some products cost a lot to ship, yet getting it there and surviving takes information. And it's getting easier and easier these days to go measure this stuff. So I highly recommend setting up a program where you ship your product and measure it. Now, for low volume, high cost products, there should be this measurement device or multiple measurement devices in every package. Now, I've received a couple of shipments of pretty good sized things that had sensors built right into the packaging, and with instructions when I received it to check those sensors to find out if there's been an excessive shock or excessive loads applied to the product, and then don't accept it. And this device would give you an indicator basically saying, hey, I've had too much moisture, or I've been shocked too much, proceed with caution before you fully accept the product. And I thought that was clever, but getting that information back would be even better. Now, I didn't detect whether this thing had any transmit or recording process to it, but it did give me information to know, was this thing handled properly during its shipment? And then you could deal with that. But measure it so that you can get the information you need about your product and your packaging in your shipping channels. The other ones out there are rude or are poor representations of what's actually happening. Now, some are better than others, but most of them really miss the mark on and don't keep up with what's going on with shipping. And then you got to design it in, right? Design your pack, whether it's got handholds or this side up or fragile things, which I think just means it's treated like a kickball instead of a box. We actually had a couple of them show up that had fragile all over the place on it, and it was obviously crushed. And the seller took the hit and shipped another product out using a different channel, different method or delivery service. But the idea is that the product itself has to be robust for its end use application. If you consider the stresses it sees during shipping, like if you don't see a lot of vibration when it's in use, from the customer's point of view, it does see vibration during shipping. So part of the design needs to account for, can I survive that vibration? Or do we need to really focus on the packaging to mitigate or eliminate that stress from occurring in our product? Those are not separate discussions. They include the product design and its weaknesses with the packaging capability, with the stresses that it's going to see. And then the question I asked right at the start, well, how many times do you monitor these things? Or how many times are these moved? And what kind of devices or vehicles or is it being moved on? I use this picture because I work with a division of HP that made test and measurement equipment. And they were finding that the evening shift, moving products from the assembly line to the test facilities and the sampling of testing they were doing, had a markedly increase in failures. And it was due to some kind of vibration or shock load that they suspected was causing the problems, whereas the day shift did not. Well, it turns out the evening shift used a different route because parts of the building were not lit or open to them. They had to do a different route, and they had a transom that a roller like this one in the picture with hard wheels would hit this transom and impart a shock up into the products. And that was enough to cause damage that a good percentage of them would fail in the evening shifts because of this route they used. During the day shift, they never found it because it was a nice smooth floor all the way. Is thinking through all of these different vehicles, all these different modes of transportation, so that you can get a complete picture. If you know you're shipping primarily by truck, it doesn't mean that you're not going to see forklifts. It doesn't mean you're not going to see hand carries. You're not going to see dollies and carts with hard wheels or soft wheels. You're not going to see gondolas. There's famous pictures of gondolas delivering packages through the canals. What series of modes of transportation and their associated stresses? So in the design guidelines, and a good information to know when you're looking at what's the profile of stresses that our product is going to see. And then when it's in use, and this one often gets covered when we design the product, is how often is somebody picking it up or moving it or transporting it or changing its location or doing whatever. It gets built into one of the features of the product, and it needs to be accounted for there. But the same basic principles apply. We need to understand what the stresses are, what the range of values are, and so on. So it goes back to measuring it and capturing that knowledge so that it doesn't get lost and can be applied efficiently by the product and packaging teams. So let's see, I think that's about all I got. So what else can be done? I'll leave that question. And our process is making sure that we don't have those out-of-box failures, right? So it is a reliability issue. If we can get a product that works or doesn't have some latent defect in it that's caused by the stresses it sees in shipping, let's make sure that it can work for the customer as expected over time, as they expect over time. And so it becomes a reliability issue, clearly. Let's see, I see a couple of comments. Yeah, so Carla, it looks like you're using a GPS system, getting lots of data. This helps with the design guidelines. Good, good. You're way ahead of where most people are that I've seen. Change in the retailer operations. Some retailers now taking products from the store shelves and shipping to customers without the outer box. It's like those shoes we got the other day. They just showed up in the box you would see at the store. They just taped it up and shipped it. And so, yeah, the shoes were fine because they, basically hiking shoes or work boots kind of thing, they would be just fine. But if that would have been, say, a sensitive electronic sensor system, and it was just rattling around in some light tissue paper inside a box, that would have probably been a problem. But I think you're seeing more and more retailers, especially over the last year and a half, 2 years, is competing with Amazon and other similar type operations, using their stores as the warehouse. And so they don't keep all the other boxes and packaging. And a lot of the parts of the problem where that they're saying, well, people ship this stuff in their cars. It should be easy on a small delivery truck. And that's not always the case. So yeah, I agree with you, Jeff, on that one. So it's being aware of all these variations to your modes of shipping does make a big difference. All right. Well, that's all I got. I'll hang on here. Let me thank you all for attending and hanging out today. Next month, I had an abstract put together, but I don't have it posted yet, is going to be about storytelling. This is one of the first times in like 6 years that I remembered what I'm talking about next month. But the idea is that let me tell you a story and how we use stories in our work as a reliability professional, and how important they are is what kinds of stories are part of our organization and culture. And so I'm going to pull it all together and hopefully make a good story out of it, but also how we can use stories. And you've heard me talk about all kinds of stories, but how can we use those stories in order to help change our organization or improve the reliability? How can we use it for influence? So that should be coming up. After that, next year, I'm pretty open. So if you've got ideas, thank you, Carla, for your suggestion on this one. And so if you got other topics or ideas you'd like to have as part of this monthly discussion, please let me know. And I'd be happy to consider those and add them to the calendar. All right.